And with that, I'm passing presenter mode over to Jithu. And in just a moment here, Jithu will be coming online.
Hey, thanks, Charles.
And there you are. And with that, I will step out of the way, and the floor is yours, sir. Thank you.
All right, thanks. So we talked about, first of all, welcome back, everyone. So yesterday we talked about several features, right? Like wildfire, antivirus, vulnerability. Now we are moving on to the rest of the threat prevention features in Palo Alto Networks firewalls. So you would have observed that each feature blocks attacks at different stage of the attack lifecycle, right? So let's see what anti-spyware is all about. So anti-spyware has two parts of signatures. One is DNS signature and DNS security. DNS security will talk as a separate topic after this. So general anti-spyware signatures are used to detect post-infection traffic. So let's say a host is being infected by a malware. Now the malware is trying to communicate to the command and control server, and we look at the traffic patterns of that communication, and we try to create signatures. And that's how anti-spyware signatures are made. So you may have a question if it's regarding if we are trying to block it using URLs, when we see the command and control connection. That is using another feature called URL filtering, which all of you are aware of. So to talk a bit about how we create these signatures, it's like, let's say malware compromises a Windows machine. It may try to update details regarding the machine, like the host information, user information, sometimes the application status present in the Windows machine, etc. in specific ways. There are specific, patterns using which we can fingerprint that, and so we can detect when the malware infects a machine and try to upload those information. We'll talk about DNS signature later, but DNS signatures, so if you have a threat prevention license, you will get DNS signatures as a part of antivirus bundle, and it is configured as a part of anti-spyware signature. So what does DNS signature look at? Let's say there is a domain called malware.com. We have classified that it's a malicious domain, and an endpoint is trying to resolve malware.com. At that point, the firewall in the middle has the DNS signature for malware.com, and we just block the DNS resolution. That's how it works. There was some capacity limitation, and that's why we came up with DNS security. We'll talk about that in detail later. DNS signature support for DNS over HTTPS was introduced in 11.0. Before 11.0, our recommendation for you was to block DNS over HTTPS so that it fails back to traditional DNS so that we can inspect it. Now let's move on to Threat Vault, because as I explained yesterday, Threat Vault is your friend when it comes to looking into any threat prevention signature. So this is an example, 85959. Let's say customer sees, okay, my authentication. Okay, let's say so this is an anti-spyware signature. Let's say a customer sees this being triggered in their threat logs in the firewall. What would they want to do first? Of course, they come here in Threat Vault, read the name. It says TrickBot Gen Command and Control Traffic Detection. If you Google TrickBot, you know that it's a very popular banking Trojan, right? So read through the description. TrickBot is a banking malware which appears to be the successor of dire banking Trojan. Currently, it's not making any effort to hide itself. It puts the word this string in its user agent. The string is not a normal string. It should not be present in normal user agents. And that's why we were very confident about about this signature not creating false positives. That's why it's critical. Action is reset both, or default action. It was released on this day. It was never updated. Status is released, which means it's currently a part of application and threat bundle. So if somebody sees this being triggered in their environment, pretty much sure that that endpoint is compromised by TrickBot Trojan, and you should follow your steps, like remediation plan, to see what's happening. So that's why I'm What I'm trying to say is anti-spyware signatures are very important, especially when it comes to critical and high anti-spyware signatures. Do not miss it when you see these signatures triggered in the firewall, because it could be at that stage where you definitely have to detect it and mitigate it. So looking at these signatures, if you look at signature exception and you click this, you can see all the signatures. So as I mentioned, majority of the signatures are regarding command and control traffic detection. There are some other signatures as well, but majority is regarding post-infection traffic. Let's move on to DNS policies. I'm going to turn off this part because this part has a separate section. Because it's a separate license, you need DNS security license to leverage this part. Now let's talk about these two parts. This is what comes as a part of threat prevention license, and this is delivered as a part of antivirus bundle. What is this? It says it's external dynamic list. This one will not show up, like if you're in the default anti-spyware profile, or if you're creating a brand new anti-spyware profile, this will not show up until you create an external dynamic list of type domain. So if you have a trusted source from which you are getting, bad, malicious FQDNs or domains, of course, the type has to be domain, right? It will show up in the DNS signatures. You could also host a web server in your environment where whenever you're reading blogs or your threat intelligence teams are giving you information, always add those list of FQDNs or domains into this external dynamic list proactively, so you can block the resolution of those malicious domains. That is something that the customer does, this part. This is where we give signatures to you as a part of anti-spyware bundle. Now, when we talk about anti-spyware profile, we have to talk about this policy action, right? Which is, there are several policy action: alert, allow, block. Everything is straightforward. What is sinkhole? So sinkhole comes into picture in a specific kind of scenario. Let me talk about two different kind of network architecture. First one, there is a trust zone, there is an untrust zone, and then there is a DMZ. So in the trust zone, there are source users, like user machines. In the untrust zone, there is the internet, and in the DMZ, there is the DNS server. So let's say the DNS query is like endpoint is being compromised, and endpoint is trying to resolve malware.com. So now the DNS query goes from the endpoint to the DNS server, which is in the DMZ zone in scenario number one. In that case, let's say you have put the action as block. The firewall will block the DNS query, and you will see the logs in the threat log. In that scenario, it's fine, because we'll be able to see the original IP that tried to resolve malware.com. Now let's talk about scenario number two, which is also common, right? There is trust zone and untrust zone. In the trust zone, which is behind in the local network of the firewall, the user devices and the DNS server is in the same trust zone. So when the DNS query goes from the user machines to the DNS server, the firewall is not there in the middle. So now the DNS server will try to query to the internet to resolve malware.com. That query will pass through the firewall. And when that query passes through the firewall, a firewall blocks it because it's trying to resolve a malicious domain like malware.com. But the issue is, if you look at the threat log in that scenario, the source IP address will be the IP address of the DNS server. So in real world, how you would see it is, I've seen some customers who have done this block configuration, and suddenly they are in the middle of some incident or something, and they are trying to find out which is the source machine that did the DNS resolution, and they are simply not able to because they fall under scenario number B. Let's see. Let me show you DNS query to make it. So this is how the log will look like. Spyware, this is the domain. Of course, resolution was trying to solve using this DNS server. And let's say, ignore this one. let's say this is your DNS server. Ignore this part. If this is your DNS server and hundreds of machines are querying this DNS server, all the source IP address will be from the DNS server. So you won't be able to identify which machine originally did the DNS query. So how do you identify that? It's using the sinkhole mechanism. So let's say if you are configuring the policy action as sinkholing, you can have a sinkhole IP address. Palo Alto Networks provide the Palo Alto Networks sinkhole CNAME. You can also put your own private IP address, or you can put the IP address of that CNAME itself. Okay, so once you do sinkholing, what happens is now again, in scenario number B, the DNS server is trying to do the DNS resolution. Firewall identifies that, oh, okay, it's trying to resolve malware.com. But the policy action is sinkhole. So I'm going to block it, but I'm also going to send a DNS response back to the DNS server saying that malware.com resolves to this IP address. So at that point, of course, the DNS server will send it back to the client, and the client will try to connect to this IP. So if you have a security policy right on the top to block all the communication to this IP address, like this IP address in the destination set to block, and you later look into the traffic logs and filter the IP addresses that have initiated a connection to this IP address, you know the machines that did the potential malicious DNS resolution. That's how majority of the people that are new implements it, and that is okay. But there is a gap with that implementation. You won't be able to know the exact domain that those machines try to resolve to unless you look into the DNS server, right? So how do you get more actionable threat intelligence information using this architecture? I'll give you something to think about because it needs some implementation from the customer side as well to implement this architecture. So let's say you have an IP address in your secure environment which responds to HTTP and HTTPS. So this is an IP address in a customer environment that responds to these two protocols, and you're giving that IP address as a sinkhole IP address. Now you are creating a security policy on the very top with app IDs, web browsing, and SSL. Of course, you have to decrypt. Decryption is not necessary in this case. So unless you want to, I would recommend decrypting the connection as well because you can see the full URI. But let's not get into that. So now, top policy, app IDs, web browsing, and SSL, and action of that policy is allow, and you're tagging a URL filtering profile to that security policy with action of all the URL categories set to drop, right? This is just to document which URL that the endpoint is trying to connect to. So let's say endpoint tries to resolve malware.com, sinkhold, endpoint gets this IP address. Now endpoint has resolved malware.com. It will connect to a URL that is associated with the domain malware.com. In that case, this machine will respond to the three-way handshake, and after the handshake, the machine will send the HTTP request, let's say an HTTP GET request. And since you're blocking all categories in URL filtering, it will be blocked by the firewall. How you get the actionable threat information is later, if you go to the URL filtering logs, put this as the destination IP and pull out all the logs for that. Maybe you can pull it out as a CSV file. You will get all the IPs that try to not only do the malicious resolution, but also the exact URI that the machines were trying to connect to. So this is like valuable threat intelligence information, and you can research further and try to identify more information regarding why those machines tried to do that resolution and things like that. Right. Another thing, you can create a security policy below that with this destination and any other app ID, and you can set it up to block. This is just one way to implement it to get more information from this configuration. Okay, this is what I just explained about. Now let's move on a bit into anti-spyware signature. I showed you an example of an anti-spyware signature in threat vault, right? What would you do when you're dealing with false positives or false negative? Let's say you're dealing with a false positive. The first thing you have to do when you are researching yourself is try to identify if user was doing something that is normal to the business when it happened, right? So if user was trying to connect to an external website and try to do something, and then suddenly the signature being triggered and user was not doing anything malicious, it's a potential false positive. Or if they were trying to do something normal to the business, in your internal network, and it triggered, it's potentially a false positive. So you try to assess it yourself, and of course you open a ticket with us and you share the extended PCAP. Yesterday I explained you how to create extended PCAP for vulnerability signature. It's the same process for anti-spyware as well. So you give us what the users were trying to do. If it's reproducible, let us know how to reproduce it. Provide us an extended threat PCAP. Then give us the threat log, URL filtering logs as a CSV output and tech support file. With this information, we'll be able to assess if it's a false positive, and we'll be able to fix it. So we'll just modify our signature and re-release it. In the meantime, you can create an exception. In case of false negative, of course, complete stream of PCAP can be provided in an ideal world. If not, you share what you have. Normally, customers identify false negative when the Palo Alto is not blocking something and device behind it is detecting it. That device would have a way to collect PCAP. So you can provide that information and we can assess if it's a false negative and we can fix our signatures. Okay, now I told you yesterday that when we are talking about advanced threat prevention features, you have to think that these are features that is above the traditional way of blocking. The traditional way of blocking is using signatures, pattern-based signatures. Now, when I say advanced threat prevention, don't think that you don't need traditional threat prevention. Traditional threat prevention is very, very strong. Advanced threat prevention is very strong as well, but it complements the threat prevention. You cannot turn off traditional threat prevention and just enable advanced threat prevention. I was asked this question by one customer at some point. So yeah, that we don't recommend it, and it will not give you a good result. So it works together with traditional threat prevention. Now let's move on to advanced threat prevention feature called inline cloud analysis in anti-spyware profile. Before we look into the configuration part, let me explain you why it was introduced. So there are some sophisticated tools, right? Like mainly Cobalt Strike, there is another one called Empire Framework, etc. So if you search for Cobalt Strike in Threat Vault, you'll be able to see a bunch of signatures that are good in detecting the traffic. But Cobalt Strike, to give some background, it was a red teaming tool created for red teaming, but threat actors are also using Cobalt Strike. There is a cracked version of Cobalt Strike as well in the internet, and attackers are using it. Attackers are using it for post-infection, the second stage of the attack. They may bring in Cobalt Strike and they may try to get backdoor in the machine that is infected and to further their attack. So the thing with this Cobalt Strike traffic is it changes dynamically. Our static signatures are good, but we reached a stage where we are not able to always detect the Cobalt Strike traffic, and detecting the traffic at that stage is very important because now you are at a second or third stage of the attack where they bring in tools like Cobalt Strike. So of course, that's where this comes in. Need the advanced threat prevention license, and you need to be on PAN-OS version 10.2 or above. So with this feature, it's a machine learning based detection again. There is an algorithm in the firewall, and when the algorithm identifies that this is a potential malicious traffic, it can upload it to the cloud for analysis. And in our cloud, we can do some machine learning based detection for these protocols, HTTP, HTTP2, SSL, unknown UDP, and unknown TCP. And we are able to call out and say that, hey, by the way, this is Cobalt Strike, so let's just block the communication. This is how the logs will look like. How you will know it was blocked by this feature is because it will say inline cloud C2 type spyware. There'll be a cloud report ID. This is something for you to refer to us if you're seeing false positive or things like that. So we can share the logs and this report ID, and we can look at things from our side and modify our detections. Of course, new feature, you don't want production impact being created by this feature. So you can always exclude URLs or IP address from this feature using this option. You can add an EDL or you can add an IP address. There is something called local deep learning that was introduced in 11.2. I've put the link here. You can search local deep learning anti-spyware. It's supported in some of the high-end models. It also, if it's locally not able to identify it, it still has the option to connect to the cloud, and where further machine learning and deep learning based detection is done. Let's move on to anti-spyware signature best practices. First one, set the action of DNS signature to sinkhole wherever applicable. Like I've talked to you about real world scenarios, right? Customers troubleshooting a breach. They know some IOCs regarding the threat actor that is, that has compromised them. So they are trying to find out the end users that tried to resolve to this particular domain. In the firewall, we can see the threat logs, but since they fall in the scenario number B that we were talking about, and they have not configured sinkhole, they're desperate, but they are not able to identify the original IP that did the resolution. So make sure, look into your architecture and configure sinkholing if it's applicable for you. Work on hardening your anti-spyware profiles. The goal should be to apply a strict profile. Strict profile in the sense critical, high, and medium should be blocked. Take some effort, but the effort that you take to block those 3 priority signatures is totally worth it. Third one, apply the profile on all relevant security policy. It's there in all my best practice. Very simple, straightforward. Make sure you apply it. Seen enough situations where it's not applied. So make sure you don't fall into that category. Leverage inline cloud analysis for additional protection. As I said, detection at this stage adds a lot of value. So make sure you configure it if you have advanced threat prevention license. Last but not the least, follow the best practice for content update to make sure the latest content updates are installed. Dynamic updates, go to the best practices, follow the security focused dynamic updates if you want to make sure you have the latest and the greatest dynamic updates installed regularly. Seen real world scenarios where content updates are like a year old. So make sure your firewall is not running with that setup. Review the best practice guide for internet gateway and data center for anti-spyware signatures. Any question before we move on to DNS security?
No, we had one question in the chat, but somebody was already able to take care of it.
Okay, thank you. Okay. Let me move on to DNS security then. It is an extension of anti-spyware features. Okay, why did we introduce this feature? I'll show you something. I'll show you something fun that will tell you why we introduced this feature. In the past, 5 years ago, before DNS security was introduced, we had these 2 options. This signature is being delivered from antivirus signature. Let's go to antivirus signature. Let's see the release notes. Okay. It says old spyware DNS C2 signature, 1925. So what are these things? These are some of these are malicious signatures that has been rotated out from this particular antivirus release. So remember, we are releasing antivirus bundle every 24 hours. This is only from one of the bundle. If you read through this, some of them look malicious, right? We are not rotating out this because of false positives or something. There may be a minor number in it which is rotated out because they are false positives. Majority of this is being rotated out simply because we don't have enough space to put everything in the antivirus signature. So 5 years ago, we reached a limitation where, there are a lot of malicious domains, right? Including DGAs and everything. We cannot put everything into the antivirus bundle. So what we are trying to do is when we have newer malicious domains, we put whatever we find is more relevant and more important in the antivirus bundle. The rest of the domains we just rotate it out of the antivirus bundle because we don't have space. Now that was the limitation. What is the solution? The solution is DNS security. With DNS security, let's say this is a malicious domain. Let's say this is a malicious domain. And this is being rotated out, right? Now, for a customer without DNS security license, when the DNS resolution happens, they don't have this option. The resolution for that domain will happen because the signature was rotated out. With DNS security, if you have configured DNS security to sync all for, let's say, malware, command and control, etc., the resolution for that domain goes through the firewall. Firewall look into the local database first, which is this one. Local database has nothing because it was rotated out. Now the firewall will query the cloud, and firewall will ask the cloud, right? Hey, cloud, is this domain a malware, or what is the category of this domain? Then the cloud will say something like, okay, this is malicious or command and control. So we can drop or sinkhole that DNS resolution based on whatever is configured here. That is the advantage of DNS security feature. So we reached a limitation and we want to make it more scalable. So now the scalability is based on our cloud, right? So another advantage of having DNS security license is we are able to detect things like DGA, domains created using domain generator algorithm, and DNS tunneling. So how does DNS tunneling work? Malware infects machine and it has got some resources that it want to send to the attacker's command and control domain. So sometimes they do it using DNS tunneling. How they do it is there'll be a chunk of data .fqdn that belongs to the attacker. Another chunk of data .fqdn that belongs to the attacker. So there'll be an initial chunk .fqdn that belongs to the attacker. So in that case, let's say that whole domain we are not aware that the whole domain is malicious. But when the DNS security server sees those DNS query, it's able to map and say that, hey, we are seeing like 10, 12 DNS resolutions to this FQDN, and it looks like a data transfer. So it will call it out. Of course, an algorithm triggers, and it says that, okay, this is DNS tunneling, and it just blocks it. And for this feature, you need a threat prevention or advanced threat prevention and DNS security license. Advanced DNS security subscription is a new offering. We'll talk about that in a separate slide. So how does this particular feature work? The policy actions are the same as normal DNS signatures: syncalling, blocking, alerting, allowing, etc. DNS signature check will be transparent to the DNS client and server for benign domains. The DNS lookups will be cached, to reduce the latency caused by this feature. There will be the connection to the DNS security cloud will be open, and it will also populate a whitelist to the firewall. Whitelist of popular domains like google.com, microsoft.com, etc. Of course, we looked at the configuration. Now you have several categories in DNS security, and you can configure the policy action as you desire. Of course, packet capture can be taken as well. There are several ways to create DNS exception based on the signature that is being triggered. If it's a local signature that is sent as a part of antivirus bundle, you can add the threat ID here, and you can click enable. This means it is exempted. I've put the CLI command to do this because when you put the threat ID here, what happens is the firewall will query the threat vault, the web GUI that I was showing you earlier, right? It will query it, and that is from where it pulls out this information. So now if there is some issue between the firewall and the connection to threat vault, this will never pop up and you won't be able to create an exception. So I just put it here as a backup. You can just do it from the CLI and it will continue to work. This is where you can create exception for a specific domain or FQDN, specifically for domains that is, okay. Several ways customers does it. One way, they proactively add important domains, like the company's parent domain or FQDN, So the attitude is like, hey, I don't want you guys to ever create a false positive for these domains, because if you block resolution for these domains, we'll have a large business impact. So we're just going to throw all these domains here. Another way to create exception is you find that Palo Alto Networks is having some false positive and you are adding it here. How do you deal with false positive? We'll talk about that in a separate slide. Now the connection, there is a connection between the firewall and the cloud, right? And there is a specific time that we have set up in the firewall for the firewall to be able to query the cloud and get the response. It is 100 millisecond, very short period of time. We don't recommend you to increase this value. Why we keep it as a short value is to reduce latency. We don't want the end user. I mean, DNS is a big part of any network, right? So if there is latency in DNS, of course, the end user will feel it. So if we are not able to get the response from the cloud within this time of 100 milliseconds, the server response is passed through the client unchanged, signature in the local database is still applied, and our approach is fail open. And when the firewall queries the DNS cloud, it also caches the output like this in data plane and management plane. These are the commands. Just you don't have to check it in a normal day. But if you're troubleshooting something or you want to see what is cached in the firewall, you can always run this command. So you run this output. You can pipe match for a specific domain or FQDN if you're troubleshooting something specifically. You'll be able to see the domain, the FQDN, then the verdict. This is just my lab, but in real world, you'll be able to see some malware, C2, etc. If you have not already subscribed to status.paloaltonetworks.com, I would recommend you to subscribe to it, because that is where we put all information regarding our cloud delivered features like DNS security, wildfire, etc. Why it is important is because, let's say, okay, DNS security is down, we'll put it here. It should be very corner cases. It would never go completely down. But scenarios where it's useful is you're subscribing to it, and one day you're getting an email saying that, hey, we are facing some latency in Wildfire Singapore cloud. So when customer gets that update, they can decide if their firewalls are connected to Singapore cloud, they can choose if they want to communicate or they want to move their firewall configuration into a different cloud, maybe one located in Australia, Japan. So you have that choice, right? But you should subscribe to know if there are any issues from our side. Of course, we will update the incident here if there are any issues, like what is the ETA for fixing, and we'll also update when the issue is fixed, etc. So since DNS security is related to connection to the cloud, you can run this particular command to see the last result. If the last result is good, it means that the connection to the DNS security cloud is fine. Of course, this FQDN should be whitelisted in the upstream devices for this feature to work. I talked about the 100 millisecond latency in the default configuration, right? How do you know what is the latency in your firewall? You run this particular command, show DNS proxy, DNS signature counters. This is a large output. So you scroll all the way down, you see something called signature query API, and you see the average latency. This is actually the latency, average latency in your environment. If it's more than 100 milliseconds, you have a problem. So how you would find out that latency is causing issues because you would have configured sinkholing for, let's say, malware in DNS security. But if you look at the threat logs, you will see the DNS security logs with action alert instead of sinkhole or block, because we have allowed it, but we are just logging it as well. So if it's more than 100 milliseconds, you should open a ticket with us. You should also look if the latency is originating from your side. So we'll try to troubleshoot if the latency is originating from customer end or if there is a latency in our server, which should be, if there is a latency in our side, we would usually know it proactively because we will get a lot of tickets and we get to know very faster. Let's say if there is any latency in customer environment, we may try to recommend mitigation using routing. And in some minor cases, you can do some minor tweaking of this value. If you run this particular command, clear DNS proxy DNS signature counters, this counter will be cleared and you can run this command again. Let's say you want to find out latency during the peak work hours of from maybe 10 to 3 p.m. or something. Clear this counter and run this counter after that work hour window, and you know the average latency during that period. Now let's move on to troubleshooting false positive and false negatives. How do you do that? So there are two features in Palo Alto Networks that work very closely with each other. So that is URL filtering and DNS signatures and DNS security. So if you see a false positive with DNS security, you can actually get it fixed using URL filtering. Corner cases, very rare corner cases where it's not fixed. Of course, you can always open a ticket with us, but it should work. So you say that this is not a malicious domain. You're saying that this is a command and control domain. Computer and internet info domain. I'm pretty sure most of you would have leveraged this page to request URL filtering category change. And sometimes when I talk with customers, the question that I usually get is, hey, we have used this feature. Sometimes the URL filtering category changes within like 2-3 minutes as soon as we submit. And sometimes the category change take like 24 hours. Why this large difference? So when you submit, this request go to, of course, Palo Alto Networks server, and we have an algorithm. That algorithm does several things. It may try to crawl the website. It may try to look into our internal threat intelligence information, and it may try to find out if we agree with your classification change. And if the algorithm is able to agree with your classification change, it will change the category right away. That's when you see the category being changed very fast. And now let's say there is a false positive and we have classified something from malware to command and control. The DNS signature associated with that domain will be turned off instantly. And if the DNS signatures was released as a part of antivirus bundle, it will be removed in a future antivirus release. What do you do in the meantime? You can always create an exception. And if it's something serious that is not only affecting you, but also affecting your customers, things like that, of course, try to change it from here first and open a critical case with us. We can give you things like root cause analysis and details regarding why it happened, and I will make sure it doesn't happen again. How to deal with false negatives. Same thing, just do the reverse. You go to urlfiltering.paloaltonetworks.com. You know that a domain is wrongly classified as computer and internet info. It should be command and control. Request a change. As soon as it is changed, DNS signature will also be released for it. DNS security will also start calling it appropriately. You can also add domains manually in EDL and call it in DNS policy to, change the action for that specific domain. So now you have used this to fix positive and false negative. Let's say you have requested for a change here. The change has happened in like 2-3 minutes. Your firewall may still have cache with the older verdict. How do you deal with that cache? You can clear the cache using this command from data plane as well as from management plane. Point to not, put it in big bold red. If you try to delete all the cache in production, it's not recommended. It could bring the firewall down potentially. So when you're doing troubleshooting with regards to DNS signature features and clearing cache, the recommendation is to clear the cache for the specific FQDN or specific list of FQDNs that you're dealing with, not the complete cache. Advanced DNS Security subscription is a recent subscription that was newly offered in the last couple of months. It detects hijacked domains and misconfigured DNS misconfiguration. So to detect DNS misconfiguration, you can put your public-facing parent domains within your organization here, and you can configure DNS misconfiguration domains here as well. We'll be able to give logs and provide information like if there is any DNS misconfiguration for these domains that you have added here, like end domains, typos, etc. How we try to identify hijacked domain is it's again using machine learning. There is a machine learning model that runs in the firewall, and we try to do something called behavior analysis. So that model tries to look at all the DNS queries in the environment and creates a behavioral model for normal behavior. And when there is a deviation from that behavioral model, the machine learning, the model is able to say that, okay, this is potential DNS hijacking, etc. Any questions before we move on to URL filtering?
We do have a question. Oh, looks like he just got answered. Never mind. We did have a schedule to take a break right now. Would you like to keep going, or?
Oh yeah, let's take a break then. Yeah.
All right. Everyone, let's go ahead and take a 10-minute break. We'll be back at the top of the hour. All right, ladies and gentlemen, we're going to go ahead and pick it up again. And over to you, Jithu. Thanks.
Yeah, thanks. Okay, so now let's go to the rest of the topics, that is URL filtering and some best practices. So for URL filtering, our team deals specifically with the cybersecurity part of URL filtering. So I'll not be covering everything about URL filtering. Not an expert in everything related to URL filtering, but just the cybersecurity part. Let's get started. So URL filtering, first of all, needs a PAN-DB or advanced URL filtering license. URL filtering can be applied as a security policy or a security profile or a policy match condition. Let's go to the firewall. Here you have URL filtering. You can apply it, like you can do whatever configuration you want for whatever categories, and you can apply it to a security policy. Two ways to apply it. One is you directly adding it as a profile here. Another way, you can create a security policy if you want to do some specific URL category related security policy. You can call it here as well. And as we discussed yesterday, it's mostly used when doing decryption. Like if you're starting decryption, you can start by decrypting specific categories that you want to decrypt, and you can create a not decrypt rule on top to avoid decryption of certain categories like financial services, government, etc. So what URL filtering does is it looks at the HTTP request from the client to identify the URL, and there is a whole process how we identify the category and enforce the blocking. We'll talk about that in an upcoming slide, but I want to explain you about something that can be a bit confusing to customers. That can cause confusion sometimes, especially when they are new to the product. Let's see a clear text HTTP communication. Pretty. You see the session end reason here, right? it says TCP fin. So there could be a lot of reason why session has entered. It could be because somebody sent a fin, or it could be because the session simply aged out. But there is a session end reason called threat, which means that it was blocked by a threat prevention related feature. And URL filtering in Palo Alto Networks is a threat prevention related feature. So how the customer may get confused is they may see the session end reason as threat. They quickly go to the threat log, they search for the source and destination, they don't see anything, and now they believe that there is something wrong with the firewall. Firewall is not showing all the logs. So understand that URL filtering related blocks will show the session end reason as threat. Easy way to identify all the related logs associated with the session is just by looking at the detailed log view. Here below, you will see the other logs associated with it. So you can see this is the traffic log, and this is the URL filtering log. You can see that the URL filtering action is alert, informational, because it's computer and internet info. And in my lab, I'm not blocking computer and internet info. If I was blocking computer and internet info, the action would be blocked, and you will see the session end reason as threat. Just some gotcha, because sometimes I get questions like that. So for HTTPS communication, you have to do SSL decryption for us to see the complete URL that end user machine is trying to connect to. We may be able to see the SNI information in the client hello domain or FQDN in some scenarios, but that is also not enough in most cases, because let's say there is a domain. We don't classify the whole domain or FQDN itself as malware unless we are 100% sure that the whole domain is compromised. So if we know that there are a couple of URLs associated with domains or FQDN that is malicious, the parent domain may be classified as computer and internet info, and those specific URLs will be classified as malware. Now, if we have a lot of URLs associated with that domain or FQDN, we assume that the whole domain is potentially compromised, and then we classify the domain and FQDN as well. So to see the complete URL, decryption is required. We'll talk about advanced URL filtering features like real-time URL analysis, inline categorization, etc. in upcoming slides. This is the most important part. This slide is important part when it comes to troubleshooting any URL filtering issues. This is how you should think about when you're dealing with URL filtering issues. Mainly the URL category lookup, like how the URL category lookup happens in the firewall. It happens in the below priority. First of all, the number one priority is given to EDLs and custom objects that the customer has created. So if you want to create a custom object like block, you can add whatever URL you want here. URLs, domains, whatever you want here. You can also create external dynamic list of type URL. These two has the number one priority. Once you create it, it will show up in the URL filtering profile. And you can configure whatever you want in these two categories. So if a URL is classified as, let's say, auctions, but it's in your, and auctions is allowed, let's say, and you have created this custom URL category and you're allowing it, this takes first precedence, it's allowed simply. That's how customers create whitelist and blacklist. Number two, it checks at the data plane cache of the firewall. So priority of URL lookup, right? It looks at the data plane, it looks at the management plane. If none of the above has the category, firewall communicates with the PAN-DB cloud to get the URL category. So if, let's say, an HTTP GET request, these things happen and it doesn't have anything, of course, the doesn't get blocked, right? We send the GET request outside. In the meantime, the firewall will communicate with the PAN-DB cloud. PAN-DB cloud will say that, hey, by the way, this URL is malicious. And when the response comes back, by the time the response comes back, the firewall will block the communication. That's how it works. Once the firewall has communicated with the PAN-DB cloud and it has got the verdict, it will put that verdict back into the data plane and the management plane cache. So the next time the lookup happens, it doesn't reach this stage. It it is already in the cache, and we don't have to do incoming PAN-DB again. On top of this, we have something called real-time detection. If advanced URL filtering license is present, you can consider it as a separate cloud that sits on top of the PAN-DB cloud. We'll talk about that later. And since PAN-DB is related to connection to the cloud, you have to make sure that the firewall itself is connected to the PAN-DB cloud. Without that, it will not work. So this is the command to check that connection status. Now let me show you something. If you go to URL filtering at paloaltonetworks.com, let's see google.com. So google.com has two categories. One, it is classified as search engine, obviously. And there is a second category called risk level category. It's classified as low risk because obviously it's google.com. So what is this risk level category? Let's see in the firewall. Let me log in again. So Palo Alto Networks have several risk level categories like high risk, medium risk, low risk, and another one called newly registered domain. While it's logging in, let's see what is recommendation from Palo Alto Networks. Like, how do you deal with these categories? Okay, this is it. Show you the configuration part in a while. So high risk category, read through the description first. Site whose domain was identified by the ML model to have properties previously linked to non-malicious domains and have low web reputation signal. Site previously confirmed to be malware, phishing, or command and control sites. The sites was malicious, but then the administrator cleaned it up. Now it's computer and internet info, but we are still calling it as high risk because it was potentially compromised at least in the last 30 days, and it remains as high risk. So you may see a site being classified as computer and internet info, and secondary category being, instead of low risk, it will say high risk. Now, you can configure it in the URL filtering profile again. There are a few risk level categories like this. These are also predefined category. So this is my lab. Don't trust this configuration. I'm just testing out some things. Okay, another thing, site classified as unknown is also classified as high risk. What is unknown? Unknown means we don't know about that website. We have never crawled that website, nor have we received any information from our threat intelligence sources. So it's also classified as high risk. The default and recommended policy action from us is alert. If you start blocking it, you may get false positives. So we recommend you to alert it, and you can, of course, look into the alert and see the unknown and other categories for for awareness. But we don't recommend you to block it. Medium risk, you have the explanation here. Default and recommended policy action is alert. Third one, low risk, you can afford to allow it because these are the benign sites like Google, Microsoft, etc. Newly registered domains. This is another category. So this identifies sites that have been registered within the last 32 days. And new domains are frequently used as tools in malicious campaigns. So the GA-generated domains can also be classified as newly registered domains, right? So the most important part is default policy action is alert, and the recommended policy action is block. So if you have just cloned the default profile that Palo Alto Networks have provided, make sure you change the action from alert to block. That is our recommendation. By the way, you cannot request the verdict change of this risk level from this website. You have to open a ticket with us. And specifically for newly registered domain, it's very strict. We don't change it if it was registered in the last 32 days. Yeah, this is a feature that is not enabled by default. It's called hold web request during URL category lookup. We came up with this feature because of popular demand, and it's configured under content ID. why did we come up with this feature? Before this feature was there, I'll explain you a bit more about how PanDB URL filtering works. When I was going through the hierarchy of how we look at it, so I told you that if there is no category in the DP MP cache, we will connect to the PanDB. The connection is always held open to the PanDB cloud, and we will ask for the verdict. But in the meantime, we will send the HTTP request outside. HTTP get or post, whatever it is. We'll send it outside. We'll query the PanDB cloud. PanDB cloud says it's malware. By the time it comes back, we are dropping the URL response. So from an impact perspective, for the client machine, the response is never reaching the client machine because we have blocked it when the response came back. But we got feedback from some of our large customers that, hey, we have external entities that is monitoring our URL filtering connection. And whenever we are being, whenever a connection or HTTP connection to a malicious URL is going out from our firewall to the internet, they are monitoring it, and it's impacting our cyber score, and it's impacting their insurance, cyber insurance. So they are trying to justify with those, those entities saying that, hey, our Palo Alto networks, this is how it works. We block the response, but that's not enough. They don't want the malicious request to go out from their firewall. That's why we came up with this feature. This was a part of feature request that came from the field, and our PM says that it'll make sense. So let's just add this feature. Feature was added a long time ago. So if you want this, if you don't want the HTTP request to even go out from your firewall, enable this one. When it's enabled, it never goes out. We hold on to the request in the firewall, we query the cloud, and we just drop it. You don't have to change it unless you want to, if there is any specific reason to enable this. Okay, let's move on to advanced URL filtering feature called real-time detection. So if you see this here in the URL filtering profile, you see a predefined category called real-time detection. You can just configure it as alert. So again, I explained about the lookup earlier. DP cache, MP cache, PanDB. What if PanDB doesn't have information regarding what this URL is about? It's unknown URL. PanDB is not able to say it's malicious, phishing, whatever category it is, right? If you have advanced URL filtering license, that you can think about it as it will be analyzed by a separate cloud where we use some machine learning based detection to identify if that URL itself is malicious, phishing, etc., based on the URLs. So let's say when you configure real-time detection as alert and real-time detected something as phishing, this is how the log will look like. There'll be URL category list where it will say real-time detection, phishing, real-time detection, malware, detection, command and control. You've configured real-time detection as alert, but the ultimate category will be whatever category real-time detection has configured it as. And if you have configured the action as phishing, the action for phishing as block URL, it will continue to block. But you need advanced URL filtering license for this. Another one is inline machine learning. So this has two features in it. One is called local inline categorization, which is this, and cloud inline categorization. For local inline categorization, it works with legacy like PanDB license or advanced URL filtering license. Cloud inline categorization, you need an advanced URL filtering license. So this works. How this works is, let's say all the other features that I've mentioned earlier did not manage to detect it. Now the payload of the web page, it's passing through the firewall. Now there is an algorithm in the firewall. There is a local machine learning model in the firewall that tries to look at the payload and try to identify if it's a phishing page. Generally, depends on what that threat actor used to create phishing pages. We will be able to sometimes identify the patterns in that page, and we'll be able to look into payload and identify that it's a potential or if it's a phishing page. Local inline categorization, machine learning model is local, and locally we are able to classify it as phishing, and we are able to block it. This is how it will look like. If local model is not able to classify it, we have the option to upload the payload to the cloud. And in the cloud, we do further advanced machine learning model. Cloud is more scalable for us, right? And that model is able to say that this is a phishing link, by the way. And it will give the category like this. It will say phishing inline categorization. Who categorized it as phishing? It could say it's local or cloud, and it will show the URL itself. We don't recommend customers to change the latency and timeout for this, but if you want to look at the latency and timeout values, you can look at this content ID setting. False positive and false negative category change, we already talked about it when we were talking about DNS security. You go to the test site, which is urlfiltering.paloaltonetworks.com, request for a word exchange, and there you have it. It will be changed within a few minutes or within like 24 hours generally. If a human has to review it, when it's changed, you will get an email response to whatever email address you have provided here. Some customers are not aware of it, but you also have the option to do a bulk change request. Let's say you have 20 or 30 URLs, and you want to change all the URL to a single category, let's say malware. You have a way to upload it. You can upload it as a CSV file like this. Or if you want to change multiple URLs to multiple category, there is a way to upload it. Again, you can upload it as a CSV file. It must not exceed 1,000 entries, and there are some other conditions as well, but there is an option to request bulk change request, do a bulk change request. While you're doing all those things to deal with false positive category changes, you can go ahead and create an exception. How do you do that? Again, go back to the lookup criteria. We first look at the custom URL category, custom EDLs created by customer. You just throw a URL into the whitelist. It is whitelisted, right? So leverage it to create exception. If it's something critical, like some of your business or very important URLs are being blocked, it's impacting you, your customer, always open a critical ticket with us, and we'll make sure it's handled very fast. The URL information that the PanDB cloud provides, the PanDB cloud has provided, will be cached in the data plane and management plane, like for 30 minutes. So you have to clear the cache. When all this is changed, if there is a cache in the firewall, it should be cleared using these commands. Test URL can be used to see if there is a cache, and the data plane and management plane cache for specific URL can be cleared using this two commands. Because if there is a cache, the cache takes precedence. Moving on to URL filtering best practices. First of all, make sure and review and enable, I mentioned, at least default URL filtering profile on all relevant policies. But that's the very basic best practice. I recommend you to, again, go and tweak it further. So default, some things to notice, default is whatever Palo Alto Networks have decided to set the action as block. Gambling is set to block, for example. Some of our customers, their main business, they are in the casino business or in the gambling industry. Of course, they cannot block gambling, right? So it depends on what you want. You clone this and you edit it the way you want, and you harden it. But default is generally a good place to start. Block newly registered domain and closely monitor connection to unknown URL, connection to unknown categories should be monitored. It will show up as high risk. Decrypt high risk and medium risk sites at least, and enables files on security policy matching high risk and medium risk site. Of course, strict policy everywhere is the best, right? And decryption as much as possible is the best, but at least decrypt high risk and medium risk sites and enable best practices on those sites. Leverage real-time detection and inline categorization for additional protection. It is the new way of detection, like sits on top of the traditional detection, but adds a lot of value. There is a feature called URL credential detection in URL filtering. It's not handled by my team. So if you have any advanced questions, you have to engage our firewall experts. But I put it here because it's very important when it comes to URL filtering. Let's see the configuration part. URL filtering. If you see the URL filtering categories, you can see something called URL user credential submission. So for any categories you want, you can you have the option to say that, hey, I don't want my users to submit their credential, corporate credential for these categories. I only want them to be able to submit their corporate credentials for specific categories that I want them to. And it is configured. For this to be configured, you should have user ID or agentless user ID configuration. Those two features are associated closely related to each other. 3 ways to do it. One is using IP user mapping. Using IP user mapping, the firewall is able to identify the username. And when that particular username is being typed into. So this feature works when everything else has failed. Web page is in front of the end user, and the end user is typing his or her username and password. That is where this blocks, and it's kind of like the last stage of credential theft, right? So IP to user mapping, when they put in the user details, we don't know the password, but we assume that, okay, they are now going to put in the password, and we are just blocking the connection. Group mapping also same. We are able to see the user information, and we are just blocking it, but we don't have the password details. If you use domain credential filter, it's more efficient, but to use domain credential filter option, you should have user ID agent. It cannot work with agentless user ID. And for this feature, you should have a user ID credential service add-on that is installed in the read-only domain controller. So it's able to see the username and password hash. And once it sees the username and password hash, it converts it using Bloom filter and uploads it to the firewall. So firewall has that information. So when the employee is going to type in the username and password, it matches with the username and password hash that is now in the firewall, and thus we are able to just block it. These are the major best practices in URL filtering. I've also put a link to URL filtering best practices. You can just Google Palo Alto Networks URL filtering best practices. It will take us to our best practice link. Make sure you follow that as well. Any questions before we move on to additional features?
There's currently nothing in the chat, so in that regard, you're good. But if anything comes up, I'll let you know. Okay,
sure. Okay, then let's move on to some of the additional features. I only have 2-3 slides left. First one, file blocking. I cannot stress how important file blocking is. Right? I've seen many situations that could have been blocked, or if not blocked, at least if the customer would have set it as alert, we could see and map how the attack happened. At least we have the file name and see how many times it passed through the firewall and what user ID, which user ID the files are associated with, things like that. So leverage file blocking. Whenever you are creating file blocking, whenever you're creating an app ID based security policy rule, think how you can put file blocking, or think how you can leverage file blocking. An example, this is just an example. Of course, I'm just using SMTP as an example for just understanding the concept. Of course, Office 365 and things like that, we cannot decrypt and we cannot do it. But as an example, let's say you're creating a security policy with app ID SMTP, and you're thinking how to implement file blocking profile. Is there a legitimate use case to allow certain file types over SMTP? Let's say file types like executables, PowerShells. Is there a legitimate use case to allow executable file through SMTP, even if it's a benign file? There is no use case, right? And again, leveraging, I already showed you in the demo how attackers use password protected files to bypass network-based protection. So think about it. Think about how you should leverage file blocking. If you, let's say, have a web browsing or SSL app ID based security policy, do you have to really allow encrypted RAR or encrypted 7-zip or encrypted zip? Is there a business use case for it? If there is no business use case, of course, why are you allowing it? There are file types like torrent. Is there a business use case to allow torrent file in an enterprise network? So yeah, think about it. Don't miss it. Underutilized feature, adds a lot of value. Yeah. Let's move on to the next one. That is Palo Alto Networks predefined dynamic list. So Palo Alto Networks provides predefined dynamic list to our customers that has threat prevention license. So these are the 4 predefined dynamic IP lists. Let's take about this one. It's called non-malicious IP address. IP address that are currently being used almost exclusively by malicious actors for malware distribution, command and control, and for launching various attacks. There's no reason why a customer should not leverage it, right? Create a security policy on the top to block, one security policy to block all the connection going on to this IP address, this EDL, and another security policy to block all the connection coming from this EDL. There have been instances where we have recommended this, and as soon as we have created the policy in customer environment, we see hits matching this policy. So make sure you leverage it. This is not a static entry, and this is not all the malicious IPs in the world that we are aware of. It's just the top 4,000 according to us, and it is delivered to customer as a part of antivirus bundle. So every day we just put the most important ones. High risk IPs, read through this description. IP address that have recently been featured in threat activity. Advisories distributed by high trust organization. However, Palo Alto Networks does not have direct evidence of maliciousness of these IP addresses. Now, it's up to you, right? If you want security focused blocking, you're saying that, hey, I'm just going to block it because it's potentially bad IP addresses, even though Palo Alto Networks does not have direct awareness of it. So just don't miss on it. It adds a lot of value, and it's a part of threat prevention license. Make sure you use it. Okay, these are some more best practices that is based on my experience working in the product over the years. First one, unknown TCP, unknown UDP, and unknown IP should ideally not be allowed from and to the internet. Why is because, what is unknown TCP? Like if you look at Palo Alto Networks Applipedia, applipedia.paloaltonetworks.com, we have a very extensive list of app IDs. So unknown TCP means it's a TCP based communication, and we are not able to identify what application it is. So we just simply call it unknown TCP. So when you see unknown TCP or unknown UDP being going too much to the internet, you investigate what it is all about, right? If it's a legitimate application that needs to be classified appropriately, you can always open a ticket or provide that recommendation in Applipedia. So we classify it as an app ID. Ideally, if you don't see anything, you can create block, especially for traffic to and from the internet, because my experience in like 90% of the breach cases that I've handled, I've seen the presence of unknown TCP and unknown UDP. It's because attackers don't always follow RFC standards throughout their attack lifecycle. Sometimes their traffic looks like normal traffic, but it deviates from the normal app IDs, and that's when it will show up as unknown traffic. So best practice, block it. Follow the best practice for securing admin access to the devices. So this link actually adds a lot of value. It is about protecting the firewall itself. And it's not a small thing, right? Protecting firewalls against attacks, against exploiting the vulnerabilities in the firewalls, like how to secure admin access to the firewall. Like if you have an interface management profile in an internet-facing interface, and you have enabled HTTPS on it, now the whole world can scan your firewall, and if it's exploitable through management interface, they can exploit. Make sure you follow these best practices. Access to the firewall should be very hardened. and it can be further hardened by keeping it in the out-of-band management interface. And you can also use security policies where only users in a specific admin group should even be able to access the firewall. There are other ways like adding ACLs, etc., to restrict communication. So make sure you follow these best practices. Don't miss it. Very, very important. Okay. I have to talk a bit about informational signature, right? Sometimes people ignore informational signature. You cannot, of course, go and set block for all the informational signature. You can set up action default for informational signature. But there are situations where you can proactively leverage informational signatures based on your knowledge, right? As an analyst, as a threat intelligence, part of threat intelligence team, etc., always leverage the information you have. I will talk about experience from my side, but our team comes in post-infection or after something bad has happened, right? So let's see. Let's see. Think that I'm dealing with situations where networker ransomware has infected thousands of machines. So I would have a few GB of logs to analyze. How would I start my analysis? If you are aware of this MITRE attack framework, this provides TTPs, like tactics, techniques, and procedures regarding, let's say in this case, networker is a fileless ransomware written in PowerShell and executed directly in memory. So these are the techniques used by threat actors that is using networker ransomware. Now, let's see. So I'm dealing with network appliance. I don't look at the local techniques. I look at network-based techniques. I'm not going to read through everything in this presentation, but I will read through everything. Let's see some parts. Ingress tool transfer. It says that operator deploying networker have used PSExec and certutil to retrieve networker payload. What are these PSExec and certutil? You may be aware that it's Microsoft signed tool that is legitimately used by administrator for admin activity. Second one, lateral tool transfer. Operator deploying networker have used PSExec to copy the networker payload across accessible systems. So again, once attackers have a foothold inside the network, they try to behave like administrators. They try to use these Microsoft signed tools so that they don't get detected. So I've seen in real world situations with this where thousands of PSExec related signature being triggered. It's informational signature, specifically this one. It says PSExec SMB v2 remote execution found. Using PSExec to copy the payload and remotely execute it on thousands of machines. So that is me looking at it from a responder's perspective. How can you look at it proactively from a protector's, like firewall manager, firewall management, threat intelligence analyst team perspective? Like when you know that there is a particular malware that is being used by threat actors for whatever your industries, finance, technology, whatever the industries, if there is particular threat actors targeting your industry in the Asia Pacific region, or even whatever region you're located, or even worldwide, read through the techniques. Or when you're reading blogs from Palo Alto Networks and other threat researchers, you read through the blogs, you find out more information, the techniques they're using, come back to MITRE, get more information. And when you read through it, see how you can leverage the signatures to block the attack techniques at different stages. If you're using endpoint protection, of course, you can look at the endpoint-based techniques as well. But let's say in this situation, a networker is potentially attacking your industry in your region. Look into it, you see, okay, PSExec is being used to copy the payload, etc. Go to Threat Vault, search PSExec, you will see a few signatures. Now, Palo Alto Networks cannot call it a high or critical signature. We'll get like thousands of calls because it's used by administrator for admin activity. But you as a customer can say that, hey, we are using PSExec, but it should only be used by a few high privileged administrators. So you can create a security policy where all the PSExec related signatures are allowed for that specific admins. For rest of the people, it's an informational signature, but just go ahead and block it because they don't need to use it. And if you're not using it at all, just go ahead and block it. So don't ignore these information. Be more proactive because a lot of attackers are proactive. We should be as well, right? Last but not the least, check out Pancast. So it's a podcast that we release where several experts from tech, professional services, product management, etc., talk about different features or fields that they're expert in. I would recommend you to subscribe and go through it. It has some cool information. Any other questions before I end the session for today?
No, it looks like there was no other questions that came up on the chat. With that, I would just like to say thank you very much, Jithu, for all of your phenomenal material between yesterday and today. I know I personally have gotten a lot out of this. I find this kind of stuff very, very, very fascinating. So anytime I can get to learn, I'm always happy to do so.
Yeah, thanks for hosting me. And I really enjoyed delivering this session as well. Thanks, everyone.
Absolutely.